discussing a Tesla space video and also a presentation I attended at Stanford last week, and they're both related. The Stanford presentation is one of their, I believe he's a postdoc or a PhD student, and he's talking about dexterous manipulation of in robotics. So this is generally just a problem of dexterous manipulation, and the work is mainly towards solving some engineering problems in terms of defining when an object is graspable and then also grasp it, of course, in a way so it doesn't get damaged. They use something called pre-grasping of non-prehensible objects. So think about it this way, like instead of grasping an object at any cost, you can nudge it in a way so it's graspable, so very similar to humans. Now, this is a very technical presentation, but I wanna use it in the same episode because the other discussion I want to have is this Tesla space video. Now, I'm just gonna say what it is and then jump right into it. So what Tesla space is trying to explain is we're on the brink of a massive, massive AI war / boom, and Tesla is going all in on AI because it is really necessary, and also it's possible to actually reap the fruits of the research. And I think the fundamental key here is something we've discussed before, which is that robotics and driving are inherently the same problem. It's really a navigation problem. Of course, they both have different applications and different fine-tuned spaces to deal with, but fundamentally it's a navigation problem. And Albert Wu's presentation actually is a good example of that. Like, we're talking about dexterous grasping, but what we're really talking about is identifying graspable regions of an object and then navigate first the thumb and then the index finger of the robot towards the actual graspable regions that are most optimal for the object to be grasped. So I like this. The reason I chose these two topics in this episode is because one is very applied, very tactical. This is what's really going on in the weeds. And the other is more general, trying to understand why is Tesla going all in? Why is Musk going all in on AI? This is not even on podcast. It's November 11, 2024. This is Krim Delco. For the day, the fund is up 11.8%. The market is up 25 basis points. For the year, we are up 69.2%. The market is up 25.1%. We're outperforming by 44.1%. The rally of Tesla since the election continues. We had a massive, massive rally. There's a couple of reasons for that. We've discussed them before. I would just summarize them in three reasons. One is that we have a really good potential for a Goldilocks environment on the macro side with lower regulation, lower government deficit, hence less inflation and lower interest rates, which should drive Tesla demand. We have less regulation, which can accelerate full self-driving and AI. And third, we also have hopefully less lawfare and less infringement on the progress of Tesla, and maybe also a little bit of a halo effect actually as a fourth. Now, let's talk about what's really going on in the trenches. I think that's really more important. So we're going to start with Albert Wu's presentation at the robotics seminar recently at Stanford. And then we're going to talk about the Tesla space video, which I think is one of the most important videos that came out of sort of the Tesla YouTube community recently. So physics-based hand dexterity planning in robotics is really sort of the holy grail of humanoid robots. And having a humanoid robot work in a factory or at home, you need to be able to move around and grasp objects and deal with objects in a way that they don't get damaged and you don't damage other people or hurt other people. And Albert's work, there's a paper attached here in the show notes. There's obviously a lot more than that. I just want to focus here because the purpose of this podcast is not to give very in-depth technical analysis of what's going on. It's really more to give an overview over what academia is doing and how we can translate academia into technology. So this is a good example. And I want to focus on dexterity here because it's really important for humanoid robots. And I think the key takeaway from the paper is that the way the problem is dissected is you have to identify a grasp space. So you have an object and you identify grasp regions on the object that are potentially good for grasping. Then you have to have a pose estimation. So you have to know where you are and what the optimal pose is for the hand, and then you have to connect that hand with the object at the optimal grasp point, and then grasp. So this is kind of really big picture how how grasping actually works. And I want to use this transition of Albert Wu's work into a more broader conversation, and this is where the Tesla Space video comes in, which is, what are we talking about here? It really is a navigation problem. And what is a navigation problem? It's a mapping problem. Where are we? Where do we want to go? What are the potential routes we can, what kind of trajectories can we take? And then what's the optimal trajectory? So it's very similar, and that's ever since CVPR, I think that's been a revelation for us, and I think for the community. DeepMind is highly involved in this, and we have people, let's say Dhruv Shah from Berkeley, who's now at DeepMind. His whole PhD was about this foundation model for robotics, which really goes into the same realm, which is, can we generalize modeling to such an extent that any kind of real-world AI / robotics can be run on the same model, or at least have a pre-trained model? And the answer is probably yes. So this is where this is going. And let me talk a little bit about the Tesla Space video. It links in the show notes. Why, the video is clickbaity. We're on the brink of an AI war, and there's a lot of talk about why that is the case. But I think what's good about the video is that there's a bit of a history of the Tesla AI effort, starting with the autopilot. They used Mobileye, then they used NVIDIA, and then they went with Karpati and actually did everything from scratch themselves. And that's where we are today. Now today, of course, we're very different than during the Karpati times. We're building now massive high throughput computing clusters, lots of training. And the key in robotics right now, as far as full self-driving is concerned, is really eval. And by the way, that's not just in the full self-drive suite of Tesla, but in general, eval in robotics, I think it's a bit of an underrated problem, because what does eval actually mean? Well, you have a model. How do you decide whether your model is good enough? How do you decide whether model A is better than model B? That's eval. And the problem with real-world robotics is that, of course, you have many degrees of freedom, not many degrees of freedom, but you have a huge action space. And you could have two models which in 95% of the action space are the same, but in certain edge cases are different, and that's really what matters. But to get to those edge cases, it could take a long time, or that's the problem, right? How do you evaluate two models? So according to Abhinav, at Tesla, this is really the bottleneck. Now, the way you solve this is, obviously, you have to have data and you have to have compute. But I think the problem is more on the data side now. How do you train a model so it can be better at certain edge cases without, of course, forgetting all the basic stuff? This is the key. And I think that's really what Tesla is working on. And I think the transfer learning from full self-drive to the robotics side is getting more and more. It's kind of like an onion, like it's unveiling itself, paper by paper, conference by conference. We're getting closer and closer to this revelation that there is really lots of synergy. Tesla has not really openly said that yet. Figure AI and others haven't said it either, but they also can't say it really because they don't have both endeavors. A humanoid robot company is a humanoid robot company. Tesla, and to my knowledge, only Tesla and DeepMind are working on both problems simultaneously. But Tesla is the only one that has production level products in the market with the cars, and is also using production level products in the factory, i.e. Optimus. So therefore, Tesla is really the only company which is able to cash in, or that's the wrong word, to grow with this space and hopefully monetize it in the future. A couple of things that the video mentions. One is the necessity to be able to interact with a robot, which is a little bit of a different problem. So that's now not a planning problem. That's not, we're not talking about how can the robot grasp stuff and get stuff done. It's more, how do I interact with the robot? And that's, one option would be voice and speech. And that's where Grok comes in, right? Grok, which is a little bit behind OpenAI and Gemini and Claude and these other models. But when it comes to speech recognition, actually, probably maybe just behind OpenAI. Now, what the video really makes a very good case for is the vertical integration. And I think we can't emphasize enough how important that is. We've been talking, we've been investing in Tesla for over a decade now, and we've been always touting the importance of vertical integration, whether it's battery, whether it's drivetrain, whether it's battery management system, whether it's manufacturing, and now with AI. Now, why is it important with AI? Like in everywhere else, optimization, hardware design, inference design, training design, model design, exploiting parallelisms, finding problems, and then just operational stuff. Once you have a problem, you can move fast. If you use OpenAI voice recognition, NVIDIA chips, and let's say NVIDIA software and chips, and then Samsung maybe controllers, you have to talk to 4 people if you want to change something. Tesla can do this in one shot. I don't want to go much further here, just simply because I think this is a bigger subject that requires a lot more in-depth research and in-depth communication. So we want to just leave it here with this episode. First, just mention it. Okay, this Tesla Space video is really important. Check it out. It's only 10 minutes. Really, nice and very important. And I think Albert Wu's paper and presentation of the robotics seminar in itself is certainly not earth-shattering. Dexterity has been solved to some extent in sim, in real. We have the Rubik's Cube and things like that. But it's interesting the way they approach it. They look at it really as a navigation problem where they have a positioning, sort of think of it like a mapping. Okay, what are the possible grasp objects of grasp space of an object? Then we have a navigation problem. What's the optimal trajectory? Then we have a pose problem. Okay, what's my pose? How should I position my hand? And then trajectory, how do I get to the object? And then how do I grasp it? I start with the thumb and then the index finger and then the other fingers, and then I go from there. So we're in early days here. I assume it's gonna move much faster. We're really excited about NeurIPS. Hopefully we have a chance to go this year to see what's going on, specifically in those areas. But I think to summarize, the transfer learning between driving and robotics manipulation is, or the linking chain is that both are navigation problems. Tesla is incredibly good position to take advantage of this and build the first real-world AI business around the car and around Optimus, and hopefully monetize these things. Now, maybe just one more tangent here. We at Orange Capital Partners have started to look at Tesla as a selling miles company, right, on the car side. And you could say the same thing about the Optimus. In the beginning, Optimus will probably just be sold as a sort of robot to do tasks. But at some point, we will morph into more as a work as a service type business model where we will sell probably problem-solving ability or something along those lines, the same way we are solving miles and not just selling cars, we're selling miles. I just wanted to put this in because this is important for various things. One is it changes the way you think about the company, it changes the way the employees think about the engineers, and of course also the valuation. Thank you.